Hey, it's James from Finney Electrical. On today's video, we're doing some testing with the apprentices. Let's get into this. Right, so into the job then. So we're going to take these through what it takes to do an Eicr test. So we've got into the property. So I think first things first then, we'll get all the light switches on then to make sure all the lights are on. So when we do the dead testing, we want to make sure we're testing to the lamp. Right, do you want to go upstairs then, turn all the lights on? So we've got metal switches, down lights. So for the down lights, what we're doing is we're going to check they are fire rated. So it's supposed to last a certain time period. The down lights, it's supposed to have like a hood over it. In fact, but that's only if there's living space above or habitable space, but this is a loft extension bit, so we can know that bit if it's not. We've got downlights elsewhere, which I don't see anything downstairs, and we should be good. So if upstairs there's a like a loft, sorry, if upstairs there's like a loft extension and there's downlights, then we'll have to sort that out. Yeah, then so into the job then. So what we've done is got the cert set up then. So all you do then, lads, is fill out the client details in. So we're just going to put the house details on both sides. And if you scroll down then, so the reason for producing this report is just that the Eicr is due on this property. So you write out the 2 dates there. If you've got any details of the existing report, you can write that in, and any, like each report's got its own ID and stuff like that, so you can bob that on there. So what's the extent of what we're testing then? So we're doing 100% testing of all final circuits. Yeah, and we're going to do 100% visual test of what's accessible. So that should cover our box. So if we can't get to stuff, or if we don't want to pull something off, like an outside light, if you think it's going to break, you're going to put that in there. What else we got? So we're just going to fill it out and say it's satisfactory for now, and we'll change it if it's something dodgy comes up. So we've got today's date. So with I think it's going to be a rented property, so the next test date is going to be 5 years, so we'll put that in for 2029. So now we're going to move on to the supplies and particulars. So what we're going to do, we're going to go to where the fuse board is and get a picture of what's going on. So the fuse board's down here. So there we go, so we can see it's non-RCD, so issue straight away then would be circuits in a bathroom have to be RCD protected, and socket circuits have to be RCD protected. So like this has got a garage outhouse, that's RCD protected, so that's good. Lights are RCD protected, but if we've got lights, there's a light circuit here, which apparently does the alarm as well, because I can hear the alarm ringing. They will need RCD protection, and so for the sockets. So yeah, should be an interesting one. The cooker as well, you know, it had that 45 amp switch on the wall. Oh, can you type in that code? It's just by the door. Yeah, causing a mess. But yeah, for here there's a socket, there's a cooker circuit here, but it's got a socket outlet, so really that'd have to be RCD protected as well. So there's maybe quite a few remedials to be done on this. So what we've said then is, first thing we do then is give everything a tighten, like a little MOT, make sure everything's tight. Took the bus bar cover off, and you want to make sure that on the bus bar actually goes into the bottom and doesn't land behind, because basically when you tighten up a breaker, it pulls like a little hook back and then clamps down onto the copper bar. If the copper bar's the other side of that, it's just going to be flapping about, so we don't want that. So what I'm going to do is get a picture of it as it is, and we can see all the cable sizes, we can see the circuit, the breaker types. We've got a B32, and then we can also see what position it is. We'll also get a picture with the front cover on, so we can see all the labels, and then we can copy that onto his schedule of tests. So next then we've got the bullet size. So it's an 80 we've got 16mm tails, and then we've got a 10mm main bonding coming in. Not bonding, main earthing coming in. And then we've got some bonding cables coming out, so you can see 2 10mm in there. So one goes to here, I can see, so we'll have to verify that. So just make sure, so when you're doing these tests, verification is also making sure it's solid on there. If it's flapping about, or if it's lost its label, we'd have to redo that then, yeah. And there should be one to the water somewhere, so we need to find the water stop tap and see if it's got a cable to it. Right, here's the pictures of the fuse board then, so we can zoom into this, get all the breaker sizes, get all the conductor sizes. Instead of kind of cramped in that cupboard, we can just do it here, sat here, and then the same again for the labels. So we're going to get this populated into this this schedule then. So this is your test results essentially, circuit details. Right then, so that's all filled out now. So essentially we've got all those circuit details. So if it's a B, it's a B type, C type, 32, 16, and then whether it's an MCB or a RCD. So there's type AC RCDs in there, and you've got type A RCDs, so that's those filled out. So now we're on to the testing them. So what we're going to do is do a continuity test first. So all we're going to do is link out line and earth at the fuse board, and then go around and test around, and the highest result you're recording. So when we add that to your ZE, which we've just done together, that will give you your max ZS. So it'll give you your ZS reading, and that has to land within these tolerances. So if you look here, when you type in the circuit details, so for a B32 it's 0.19, for a B16 it's 2.18, so it has to land below that number, otherwise it fails, yeah. Alright, circuit 1 then, bang him off, take him out. That'll do. And what we'll do, a little crocodile clip, bang on there, bang on his earth, and then we're going to go and test that cooker. So this is going to give us the resistance from this line all the way into the circuit, all the way around, all the way back to earth, so when we test on that end. Right, we've got a result there, so 0.27 in that socket, so 0.27 is what we're at for the R1, R2, and then we're going to obviously add on your ZE to give you your ZS. So ZE we're what? 0.30, so that's now 0.57. Does it land under this tolerance? For a B32, does it land below 1.09? Yes it does, so that passes. So now obviously we've pre-filled all these greater than 200s. We're going to do insulation resistance. It's going to send the voltage down between line to earth, neutral to earth. Yeah, we'll fill out the results. There's also, yeah, line to line, line to neutral. So if it's 3 phase, you'd do between your lines, wouldn't you? But yeah, we're going to do line to earth, line to neutral. So now what we're going to do is do insulation resistance test then. So I'm going to take the neutral for that circuit out, which is this one. So it's just done. So you can pull him out. So that's that 6mm. Yep. And then what we're going to do is put this on insulation resistance. So it's going to send 250 volts down it. So we're going to go from line to earth, yeah. So we could use crocodile clips, but I'll just push on quite hard. And there we go. So if you look down there, greater than 200, yeah. So like, you know, that light we pre-filled already. We pre-filled it's greater than 200. We'll do neutral to earth now. It's just climbing and climbing and climbing into it. So 174 we'll put down as worst, and then obviously line to neutral. We've turned the isolator off, and that'll do. So anything the lights, well, anything over 2 meg, anything over 1 meg actually passes. But if you're getting down towards 1 meg, there might be some issue that you might want to look into. So we've done a radial circuit on camera. Should we do a ring next and show you how we do a ring test? Essentially it's just rinse and repeat, rinse and repeat. There's nothing special after that. Once you've done a radial circuit or a ring circuit, they're all pretty much the same thing. So you connect up, line to earth, test it at all your points, and then you do this buzz bar covers, good, needs clipping in. And then you obviously disconnect your loads and then do neutral to line, neutral to earth, line to earth. There you go. Right, we're just had a go at trying to take the cables out so we can do the end-to-end test for the sockets. So you obviously test from there to there, neutrals all the way around, but we can't find out which earth's earth for this circuit because it's we just can't find it. We can't dig in there because it's that rammed. So a good trick then is to go into the circuit then. So we're going to go into find out what's dead, go into it. I'm going to split a socket and do the end-to-ends at the socket where we can actually split the earth and check we've got earth continuity all the way around. So nice little tip there. So we're going to actually, we can get insulation resistance test here, and then we'll bang it back together and then do the end-to-ends on the socket, and R1, R2's on the socket with this breaker off, but the cable's in. There we go, lads. So this is the socket we decided to undo. Yeah, look at this, lads. This is what people like to do, is twist the earths and use this one sleeving. So we can undo that, do all this, and then we'll put it back properly. We'll put it in 2 different sleevings, so we'll have to get some sleeving out. It's just annoying. Imagine this in a fuse board, you've got to pull it all out and untwist, twist. So that's separated. So can you get crocodile clips? So it should be in my little box. There we go then. So end-to-end test then. Just going to bang that on there, bang that on there, bang that on continuity then. There we go, continuity mode. So obviously we've already nulled those leads, but essentially if you're to do it, you just bang it on, hit 0, and that will actually null the leads. And then when you press test, you get 0. Right then, can you hold that there? Lovely. So you do line. This is an end-to-end for line. And we're not getting anything. Is it that one? One of these is a spare, that's why there's 3. Oh, there's a break. There we go, it's just M2. So 0.44. And then let's do neutrals. 0.47. It was the ace we couldn't get to, wasn't it? So let's do that one and that one. Oh, I tested the wrong cable. Why is there just no end-to-end on the earth? Great, so we've got no end-to-end on the earth. So this is where you check it. If we just gone, yeah, it's going to be earthed. But there's some break in the earth somewhere. Because look, that's not good, is it? Greater than 2000. So I'll have to look into that. I'll put it down as an observation. There's no end-to-ends for circuit 2 for sockets. Yeah, that's what we'd write down. No end-to-ends on the earths. So Harry's just doing a bit of testing now then. I'm going to record the highest reading. So what we've done is just connected all lines and earths together. But yeah, because it's not on end to end, we can't do the figure 8 test to do the R1, R2. So if we can't find that, we're going to have to, well, we're going to have to derate it to like a B20, something like that. And then essentially you've just got 2 radials, and if everything's got an earth, then you're fine essentially. So we're going to test each socket. We're testing both sides of the socket, because I've had it where one side's been good readings, one side no earth. So, or you can't plug it in, or there's like a live pin sticking out or something, you know? You gotta check it out. So Harry's going to get the highest reading, and we'll wrap that in, but we'll put it down, that further investigation, to see why there's no earth continuity. There we go. There we got sockets back now then. So we've tested one upstairs and we've got some more dodgy stuff going on. So this socket's on 32, so the max that can take with 2.5 cables, so one 2.5 can take 27 amps. As a ring it can take over 32. However, so this is on a 32, it's wide enough as a ring. So 2.5 cables come out. And we'll just test this socket in here then. Look at this. Yeah, it's not big for this yet. What we've got a 1.5 cable doing the circuit, look for neck. So 1.5 kit can barely take 16 amps. So it's on a 32, so basically if you overload that socket, I'll plug in a heater or a couple of heaters, that cable's just going to set on fire. So that's good, isn't it? So what we're going to have to do then is downwrite this to a V16 or rewire the cables that are wired in a 1.5 cable. So it's got tested quite a few years ago, but this has been in since at least 2005 because it's the old colours. So whoever's tested last did not do a good job and just probably just went around and made up the certificate. So some people do that, they'll do like a £100 test and then they're there for 10 minutes. They'll write out the schedule, write out the circuit details, and then that's it. Done. Get paid, and customers none the wiser. Whereas little Granny Smith could plug a couple of heaters in because she's cold and she's on fire. The cable will just melt, set on fire, so that's not good, is it? Yeah, we're just testing the loft sockets now then. I'm gonna get 0.51 then. Yeah, look at this. What's this little hatch? Yeah, look at that nice little junction box. That's looking after the spark, isn't it? So yeah, look, this company's obviously boarded this out and thought, oh, then I might need to get to that. Genius. Look at that for a view. Like that, isn't it?
Beautiful.
Look at that for a drop.
Beautiful.
Okay. Yeah, look at this end. So, this is smoke alarm. Just got to check the date on this. I've checked it already downstairs. They were 10, what were they done? 2020. So now they come with 30 years lifespan on them. So that's good for another, what are we, another 6 years. Oh, flipping it a bit sketchy to come down those, mate. Right then, well, that's as far as we can take it then really. So we've got everything tested off. So unfortunately we didn't be able to get a ring to show you a ring test because there is no rings because they're all dodgy. So what we'll have to do then is just recommend a fuse board changeover then. Because to get breakers to fit that board, it's sat tight in there and they're that tall, they RCBOs, you won't fit them in. Yeah. So it's going to be a board changeover. RCD protection on everything, so there's no RCD protection on sockets downstairs, in the bathroom circuits. You know what I mean, so it's not right good, is it? So, and then we'll downrate the breakers then. So they're only doing like sockets upstairs, so it won't be a big issue. There's obviously the fault finding here. We might have to downrate this to a 20, but it's a gas appliances, isn't it? So we might get away with it. Obviously if it was like a big electric, I don't know. If you had lots of appliances here, I think it's only a washing machine and a dishwasher. But if you had loads of like plug top appliances like single oven and stuff like that, if you plugged in 3 appliances, it's going to trip you 20 amp into it. So I think we'll get away with that. Lovely. Now then, Herbie, what have we learnt today then for a bit of testing?
So today I've learnt what volt you need to test, like insulation resistance, and also...
So was that 250 now, isn't it?
Yeah, 250, and also
what other test did we do then?
what other test? So we did continuity. And we
so that's to check what? There's earth everywhere.
Yeah.
Make sure you don't get electrocuted with anything metal.
Yeah.
And it also makes sure that the breaker's tripping sound, doesn't it?
Yeah. We also did an end-to-end test.
So well, we tried to. We got line, neutral. But what?
Oh yeah, the earth wasn't work. We didn't get a reading for that.
No. It was a bit dodgy, that circuit,
yeah.
Wasn't it? So it was on 32, no end to end. So we're gonna have to do an investigation into that. If we can't find it, then we're gonna have to downrate it to like a 20 or something, just so it's classed as like a radial. There you go. There we go. So then, if you like this kind of content, then hit the like button, hit subscribe, hit the little bell notification so when next upload. So as always, I'm going to from me and Herbie, and we'll see you on the next one. Don't know where Herbie's gone.